Heat and temperature are often thought of as the same thing, but they are not the same. According to a NASA data center, heat is the total energy of molecular motion in an object. Temperature is the measure of that energy. Heat also depends on the size or mass of an object. For example, a hot tub has more heat than a cup of hot chocolate because they are different sizes. The hot tub and the hot chocolate can be the same temperature no matter the size difference. Heat cannot be measured directly. Temperature, on the other hand, can be measured using a thermometer. Heat can also change temperature. When the molecule movement in an object slows down, temperature drops. But when the molecules speed up, the temperature rises. Sometimes an object gets hot very quickly. Some things take a while to heat up. So does heat transfer the same through different materials? If so, why? To gather evidence about this question, I collected data from many different sources and I also conducted an experiment. When an object heats up quickly, it's called a conductor. When an object heats up slowly, it is called an insulator. Conductors have tons of molecules packed tightly together. Once a molecule gets heated, it begins to move around. By moving around, it passes heat along to other molecules until they are all hot. This is called the process of conduction. When molecules are tightly packed together, heat moves easily and quickly throughout the object. With an insulator, things are very different. Insulators do not let heat transfer easily. The atoms inside of the molecules do not allow free flow because of tightly bound electrons. Since the electrons are bound, the molecules can't roam around to bounce heat off of one another. Because of this, heat rarely distributes across the object. Okay, so for my experiment, I have a wooden spoon, a plastic spatula, and a metal spoon. I'm currently boiling water to put my objects inside of it. As you can see, the water is very hot. Starting with 30 seconds, I'm going to put the objects into the water. Okay, after 30 seconds, we'll take all the objects out. The plastic is warm, but I can hold it. The wood barely feels warm except at the tip, and I can still hold on to it. The metal is hot to the touch. I can barely touch it, let alone grab it like these two. So my experiment has proved that metal is a great conductor and wood and plastic are more of an insulator. So while cooking, that's why you might realize that you use more plastic and wooden utensils than metal. Even this pan, metal for where it will get hot, and the handle where you touch it is coated with thick plastic to insulate the heat. For my evidence, I found that conductors have tight-packed molecules that bounce off one another to distribute heat. The molecules in an insulator cannot bump off one another to transfer heat, so the material does not heat up as quickly. During my experiment, I heated 3 objects in a pot of water at the same temperature and time, and heat-wise, none of the objects felt the same. The evidence and data that I have collected prove that heat does not transfer the same throughout different materials. My reasoning is this. Because metal is a conductor, it got very hot very quickly. But in the same pot, the wooden spoon did not get nearly as hot because it is an insulator. Some children may believe that objects like blankets or sweaters create the actual heat, when really it is insulating their own body heat. Some may have trouble explaining that heat is a type of energy. They may instead say heat is a thing or a substance. Finally, some may think that hot and cold are opposites, But really, cold is just the absence of heat.